Graphing velocity, distance time graphs. It can be difficult to make sense of a table full of numbers that show distance and time, or any numbers for that matter. If you plot these numbers on a graph, you can see all the information at once. Velocity graphs are called distance time graphs. Okay, if you're using displacement, you change in that or change in position. Instead of distance, you call them displacement time, and we'll get more into that here in a minute. When you draw distance time graphs, time is plotted on the x-axis. Remember, that's the horizontal one, the one that goes back and forth. Okay, the distance is plotted on the y-axis, and that's the vertical axis. That's the one that goes up and down. The line of best fit that joins the data points gives information about the velocity. So take a look at the graph below. Notice that the title provides two pieces of information. One, it identifies the object being studied, okay, which is a lawnmower in this case. And two, it identifies the variables that are being measured for the graph. In this case, it's distance and time. We say it is a distance time graph for a lawnmower. This is an important point because when you make graphs, you should always give them an appropriate descriptive title. The two axes or axes show the following pieces of information. They show one, uh, the units for each variable. So time is measured in seconds on the x-axis at the bottom, and distance on the side, the left side there, is measured in meters, okay, on the y-axis. The x-axis shows the independent variable, okay, which is the one variable that is purposefully changed in an investigation. Remember back to grade 9 here, okay, in the scientific method. Here, the independent variable is time. Sometimes the independent variable is called a manipulated variable. Since you manipulate it, you change it, right? Since it is a factor that is changed by a researcher. Y-axis shows the dependent variable, which is the variable that is measured as it changes in response to the independent variable. Here, the dependent variable is the distance the lawnmower travels during each time interval. A dependent variable is also called a responding variable because it changes in response to the independent variable. Slope of the line shows that the lawnmower in this particular case is moving at a constant rate. The graph on the left shows a straight line, which indicates a constant velocity. The graph on the right has a jagged line or a curved line. This indicates the velocity of the object changed over time. And this is only on a distance time or displacement time graph. Okay, you're going to see later on, we're going to look at other types of graphs. And for example, a velocity time graph, which is an acceleration graph. These lines will look different in different circumstances. You can use distance time graph to determine the velocity of an object. To do this, you calculate the steepness of the line in a distance time graph. This is called the slope, okay? Now the slope formula. The steepness of a line on a distance time graph represents the velocity of the object being studied. The steeper a line is, the faster the object is moving. So I give you an example here, okay? We see the green line, that's a fast, steady speed. Okay, there may be times when you see the red line where we have a steady speed, right? When it's flat and horizontal on a distance time graph, that means it is stationary or it's stopped because you can see time is passing, but distance is not changing, right? And then we have it returning to the start, right? Slowing back down to zero from its speed. Okay, and then the blue one, this is it gradually getting faster. okay? Not a constant speed, but it gradually getting faster. The steepness of the line is called the slope, okay? You can use the slope of a line to calculate exactly how fast an object is moving. Okay, use these steps to find the slope. First, you want to choose 2 points on the line. Identify and record the coordinates of the 2 points. For example, mark the numbers on the x and y axes for each point. 2, find out the rise. This is the distance interval between the 2 points. To calculate rise, find the difference between the 2 y-axis points. Find the run. This is the time interval between the 2 points. To calculate the run, find the distance between the 2 x points. 4. To find the velocity, divide the result of step 2, the rise, by the result of step 3, the run. Okay, so you can see this this representation here. Remember that the equation for velocity is distance over time, and so just so you understand, rise, remember, is the difference in the distance, and run is the difference in the time. And so essentially, because distance over time equals velocity, rise over run equals the slope, which is the velocity of the line. Okay. So on this one, we're going to choose 2 points. So step 1, we're going to choose 2 points. We're going to choose 2 and 2, okay, and 4 and 4. So the 2, 2 for the x, 2 for the y, 4 for the x, and 4 for the y. So now we're going to calculate the rise. So remember, the rise is the distance. Okay, so we're going to take that 4 and we're going to subtract the 2, and that's going to give us 2. Now for the rise. Then we're going to calculate the run with the 2 x values. Okay, so we're going to take 4 and we're going to subtract 2, and that's going to give us 2 as well. Now to calculate the slope, and you've probably already done this in your head, okay, you're going to take the rise over the run, so 2 over 2, which is equal to 1 meter squared. Calculate the velocity of the go-kart by calculating the slope below. Okay, so I want you to calculate the slope of this line. Remember that you have to choose 2 points which intersect. Okay, ones that would intersect would be for an x value would be 1, and for a y would be 15. Okay, you could also choose 3.5 and 50. You could also choose 4.5 and 65. Okay. I want you to do that problem, calculate the slope of the line according to what I've just showed you, and we're going to go over that in class together.